Hello everyone. So welcome to the class again. This is a chapter from Ganita Prakash, grade 6 CBSE prime time. So this is the second video in the video series of prime time. So today we will learn about these factors and divisors by playing a simple game. So let us get started. This is called Jump Jackpot. Jumpy and Grumpy play a game. Jumpy places a treasure on some number. For example, he may place it on 24. Jumpy has to choose a jump size. If he chooses 4, then he has to jump only on multiples of 4, starting at 0. Jumpy gets the treasure if he lands on the number where Jumpy placed it. So which jump size will get Jumpy to land on 24? So this is like a number line. So the treasure is at the number 24. So different jump sizes can lead to this 24. So let us check out all the different options. For jump size 4, Jumpy jumps from 4 to 8 to 12 to 16 to 20. And finally he reaches 24. So 4 is a good choice. So if he chooses jump size 4, Jumpy lands on 4, 8, 12, 16, 20 and then last on the 24 where the treasure is lying. So he gets the treasure. So let us see some other jump sizes. If he chooses the jump size as 6, first he reaches 6, then 12, then 18, then again 24. So 6 is also a very good choice. So 6 lands on 6, 12, 18 and 24. 8, what happens with 8? For 8, the Jumpy lands on 8, 16 and 24. So 8 is also a very good choice. So what about jumps of sizes 1 and 24? So let me tell you a fact that 1 and the number itself are always factors of the number. So 1 and 24 will be also very good jump sizes for this number 24, because 1 is a factor of every number and every number is a factor of itself. So these two are also good choices. So these numbers, like for 24, the numbers 1, 2, 3, 4, 6, 8, 12, 24, all these numbers divide 24 exactly. Like they don't leave any remainder when you divide all these numbers. When you divide 24 with all these numbers, you don't get any remainders. So these are called factors or divisors of 24. Now, level 2 of the game, Jump Jackpot, level 2. The Grumpy increases the difficulty level of the game. So now, instead of one treasure, he keeps two treasures, or rather you can think it as one he keeps the treasure box and another he keeps the key, so that you need to jump on both the things to finally get the treasure. So your Jumpy has to now choose a jump size and stick to it like before. And Jumpy gets the treasure only if he lands on both the numbers with the chosen jump size. So as before, Jumpy has to start from 0. So what numbers? Jumpy now keeps the treasure on 14 and 36. And Jumpy chooses a jump size of 7. So will Jumpy land on both the treasures and finally unlock his treasure? Let us see. He starts jumping from 0. So he lands on numbers 7, 14, 21, 28, 35. Then directly to 42. He doesn't reach 36. So we see that he landed on 14, but he doesn't land on 36. So he doesn't get the treasure. What jump size should he have chosen? The factors of 14 are 1, 2, 7, 14. So these jump sizes land on 14. The factors of 36 are 1, 2, 4, 6, 9, 12, 18 and 36 itself. These jump sizes will land on 36. So what are the common factors? Common factors are only 2, 1 and 2. So these two jump sizes will land on both 14 and 36. So these are called the common factors. Let us do some figure it out from this section. Find all the multiples of 40 that lie between 310 and 410. We know from the fours table that 4 into 7 is 28 and like that 4 into 11 is 44. So if we multiply 4 into 10, then we get 40. So 40 into 7 is 280. Similarly, 40 into 11 is 440. So these two are out of range. 40 into 7 is below the range of 300, below 310, and 40 into 11 is above 410. So between these two ranges, we get all the multiples. So the multiples are 320, 360, and 400. Next problem. Who am I? I am a number less than 40. One of my factors is 7 and sum of my digits is 8. So the numbers which are less than 40 and also are multiples of 7 are these numbers. All these numbers, these multiples have a factor of 7. So these satisfy the first two conditions. Now, which of these numbers have sum of the digits as 8? That is 35. So the answer is 35. Now the section B of the second problem. I am a number less than 100. Two of my factors are 3 and 5. One of my digits is 1 more than the other. So two of my factors are 3 and 5. So what is the first number which satisfies this? That number is 15. So all the multiples of 15 we have listed till 100. Less than 100 we have listed out all the numbers which are multiples of 15. So out of these numbers, one of the numbers have two digits which are one only apart. One difference of the digits is only 1. So what number satisfies this condition? That is 45. Let's go to the move on to the next number. A number for which the sum of all its factors is equal to twice the number is called a perfect number. The number 28 is a perfect number. The factors of 28 are 1, 2, 4, 7, 14 and 28. If you see the sum 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 7 is 14, 14 plus 14, 28, 28 plus 26, 28, 56. So their sum 56 is twice 28. Such numbers are called perfect numbers. So find a perfect number between 1 and 10. So the number is 6. I will in a separate video, I will tell how to derive perfect numbers. So I will cover that in a separate video. For now, this you have to know that between 1 and 10 there is a number 6 which satisfies this condition. The factors of 6 are 1, 2, 3, 6. So if you add 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 6 is 12. So 12 is basically twice the number 6. So the answer is 6. So find the common, next fourth problem, we have to find a common factor of a few numbers. So first is 20 and 28. So the 20 has all these factors 1, 2, 4, 5, 10, 20 and 28 has 1, 2, 4, 7, 14 and 28. So out of these factors, what are the common factors? The common factors are 1, 2 and 4. So next one B. The factors of 35 are this. I will not tell each and every one, each and every number. So the common factor are 1 and 5. Next is 4, 8 and 12. These are the factors. Then the common factors are 1, 2 and 4. For D, there's 5, 15 and 25. These are the factors. The common factors are 1 and 5. Let's move on to the next sum. Find any three numbers that are multiples of 25 but not multiples of 50. So let us list out the multiples of 25. So out of these numbers, if you see, then those numbers that doesn't end with a 0, they are not multiples of 50. So these are the numbers 25, 75, 125. Sixth sum. Anshu and his friends play the Idli Vada game with numbers that are both smaller than 10. The first time anybody says Idli Vada is after the number 50. So Idli Vada means first common multiple is greater than 50. What could be the number? What could the two numbers be which are assigned to Idli and Vada? So there could be different possibility. There is not just one set of numbers which satisfies this. So we will look at each of the conditions. So the smaller number has to be greater than 6. Why? Because larger number has to be 9 or less. So if you see 9 into 5 is 45, which doesn't satisfy the condition that the first common multiple has to be greater than 50. So the smaller number has to be greater than 5. But the first common multiple of 9 and 6, that is also not 54. It's not a direct multiple, because they share a common factor 3. So the first common multiple is 18. So that is also not satisfying the condition that the Idli Vada number should be after 50. So the smaller number has to be greater than 6. So it can be either 7 or 8. 7 and 8 has the first common factor is 56. First common multiple, sorry. First common multiple of 7 and 8 is 56. And 7 and 9 is 63. And 8 and 7 is 72. So all these are satisfying the condition that the first common multiple should be greater than 50. So all these three combinations are satisfies this problem. So the answer is 7 and 8, or 7 and 9, or 8 and 9. Any of these three combinations. So let's now move on to the next one. In the treasure hunting game, Grumpy has kept the treasures on 28 and 70. What jump sizes will land on both the numbers? So we have to list down the common, first we have to list down all the factors of both these numbers. Then we have to find the common factors. So these common factors are the jump sizes that land on both the numbers. This is the next problem. In the diagram below, Guna has erased all the numbers except the common multiples. Find out what those numbers could be and fill in the missing numbers in the empty region. So the common multiple starts with 24. So there are different combinations possible. First combination is 3 and 8. 3 and 8 doesn't have any common factor, so their first common multiple is 24. 6 and 8 also satisfies this condition. 12 and 8, and also different combinations are possible, like 24 and 3, 24 and 8. All these combinations are also possible. Find the smallest number that is a multiple of all the numbers from 1 to 10 except 7. So all these numbers, I have not included 7 here. So all these numbers, first common multiple, smallest number that is a common multiple of all these numbers. So what we have to do is, we have to do 1 into 2, then 3, then 4 we will take only 1, 2, because already we have taken 1, 1, 2. Then 5 as it is we'll keep. Then for 6 we don't want to add anything because already we have 2 into 6, 2 into 3. Then for 8, we have to add one more 2 here. I'm going to multiply one more 2 here to this problem. For 9, we have to add one more 3 here. And for 10, it's already taken care of in this 5 and 2. So these, we have to do a multiplication of all these prime numbers to get to the product. So the final answer is 360. Next problem is just an extension to the previous one. So find the smallest number that is a multiple of all the numbers from 1 and 10. So previously what we have done, so that same number we have to multiply 7. So we get the answer 360 into 7, that is 2520. So that's all for today's class. Thank you so much. And please don't forget to like, subscribe and share. Thank you again.